I think two to three different examples we have discussed and how we have written, right?
Yes, sir.
Based on that, am I said about formal charge? What is formal charge
No, sir.
and how
No,
to
sir.
calculate formal charge of atom
No, sir.
and the limitations of
No,
octet
sir.
rule, something?
Not
Sir,
done,
you
sir.
were saying about Lewis dot structures.
Okay, okay. So I think Lewis dot structures we have done, right? And after
No,
that,
sir.
we need to
There is
calculate
said
the.
the steps, procedure, and some examples.
Yes, okay. Next one. After that, we are going to discuss about the formal charge. Okay, formal charge. So formal charge we can define as the formal charge. Formal charge on atom in a molecule is the molecule is defined as difference between number of valence electrons difference between number of valence electrons of that atom in the and number of electrons assigned to that atom in Lewis structure. Sent to the atom in Lewis structure. And formal charge can be calculated as formal charge I'm going to indicate it as Fc, which is equal to total number of valence electrons of the atom total number of valence electrons of the atom minus total number of electrons of lone pairs. You need to remember the formula, right? Minus half into total number of shared electrons. Okay, this is the way we are going to calculate the formal charge. Okay. Okay, now students. So, for example, let me take, for example, I want to calculate the example, calculate formal charge on each atom of oxygen in ozone. Okay, that means he is asking in ozone. We need to calculate the formal charge of each and every atom. We need to calculate. First, what we need to do? First, ozone. We need to write the Lewis dot structure, right? Uh, so, how we will write ozone Lewis dot structures? How we will write an ozone Lewis dot structures?
Sir, one doubt, sir. Why
Hmm.
did we write of minus 1 by 2?
Formula on it is
So we had to do into 1 by 2, sir.
minus half into total number of electrons.
Okay, sir.
Mm.
Sir,
Mm.
sir, we take one oxygen in the center, sir, and then sir, we give it. Sir, we can give double bond between one electron.
First, what we can write? Ozone, sorry, oxygen, right?
Yes, sir.
Double bond and single bond here. And how many electrons we can write? Lone remaining all will be
The
lone pairs,
lone
right?
pair center oxygen 2, sir.
Mm. Left also 2 and right side 3, right? That's it only, na? Now
Yes,
let me assume this is oxygen number atom 1. This is oxygen atom number 2. This is oxygen atom number 3. Okay. Now let me say, uh, first I'm going to calculate for one atom. You need to calculate for remaining two atoms. Okay. Formal charge of oxygen 1. Okay. What is the formula we can write? Number of valence electrons of oxygen, how much it will be there? 6, right?
Yes.
Number of electron lone pairs. That is oxygen valence is 6 minus how many lone pair of electrons are there? These are lone pairs, right? How many lone pair of electrons?
sir.
No, no.
4.
Minus 4, 4, no?
Yes, sir.
Because two pairs of the 4 minus half into how many bond pairs are there here? These are bonded electrons. So one bond
Sir,
means how many?
4.
Huh?
4, sir. Double
Uh,
bond, sir.
Double bond means 4. That means what we can say it will be 0. Okay. So formal charge on oxygen atom is 0. First oxygen atom. Now do it for
Sir,
uh,
sir, I have a doubt. For
mm,
oxygen, the first atom, there are double bond, no sir, plus two lone pairs. That means we that have 8, no sir.
mm.
Then you wrote here 6 minus 4, sir.
Rare formula total number of valence electrons of the atom. Oxygen, how many valence electrons are there?
6, sir.
That way I have written no formula for as per formula.
Sir, for oxygen number 2, we'll take 6 number of lone. Sir, 6 shared electrons, sir.
Same.
Between
1 second. Let me take. So
single
F.
bond also there.
So Fc on oxygen 2. So number of valence electrons are 6 minus how many lone pair of electrons are there? 4
4.
minus half into how many
6.
bond pairs?
6.
2 plus 1, total 3 bonds. So this oxygen is involved with 3 bonds, right?
Yes, sir.
So this oxygen is involving with 3 bonds. So that 3 bonds means 6 electrons. So 6. So how much charge we will get? Uh, minus 1, right?
Yes, sir. Sir, if it's involving in 3 bonds, then total number of electrons in it would be 10, sir.
10, how it will be? 1 bond means 2 electrons. No, 3 bonds means what? 6 electrons, right?
Yes, sir. And lone pairs are 4.
Hmm.
So total it will form 8, 10 electrons, na sir. It should only form octet or duplet, na sir.
Okay. Sorry. Here it is 2 now. Sorry. Only one lone pair only. Sorry, I had written wrong. Okay.
Okay,
So
sir.
here it will be how much? It will be 2. Okay.
2.
So that means it will how much? It will be plus 1. It will be. Next, formal charge on oxygen numbered as 3. Same, no? 6 electrons. Minus how many lone pairs are there? 3 lone pairs, that is 6. Minus half into how many bond pair of electrons are there? Only one bond, no? That is 2. So it will be how much then? It will be minus 1. Okay. Okay. Let me solve one more example. I think you will get. Calculate formal charge of sulfur in HSO4 minus. So in HSO4 minus, I want to calculate formal charge of sulfur.
Sir, this can we do, sir?
You do only, that all I'm asking now.
Sir, can you show the previous slide?
Done? Mm.
Sir, one second. Sir, sulfur valency electron 6, na sir?
Mm.
Sir,
Ah.
sir, in the oxygen atom too.
Sir, I got a formal
One
charge.
second. One second. Somebody is asking. In oxygen atom 2, tell me, Nana.
Here we go, how did we get plus 1? No, sir, here again minus 1 by 2 we cut and it came as minus 1. No, sir.
6 minus 2. 2 1 ja, 2 3 ja, minus 3. 6 minus 2 minus 3 means how much it is? Minus 1 or plus 1 only, no?
Oh, like that. Okay.
Sir,
Okay,
I
na?
got formal charge is plus 0, sir.
0.
Yes, sir. 6 minus 0. Sir, lone pair would be 0, na sir.
Mm.
Sir, 6 minus 0 minus 1 by 2 bracket 12, sir.
12 you have written.
Yes, sir. HSO4, na sir.
Mm.
6 minus 6.
HSO4 minus, right?
Yes, sir. Oxygen minus 1.
Anyone answers? Other answers, students?
Sir, 0, sir.
0. See, let me try that. So formal charge, how we will write? Sulfur, no? So sulfur, okay. Total how many we will write now? See here. Oxygen, oxygen, Mm, as per Lewis dot structure, right? 4 plus O H O minus. Likewise, we have written 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, and here we have 3 lone pairs. Okay, sorry. So Lewis dot structure, no. So here we will have single bonds only. Single bonds will be there, Nana.
Sir, but we can take
No,
sulfur.
no. Actually, we can't take uh, 2. Why? Because as per Lewis dot structures, no, it cannot have beyond 8 as oxidation state. So the octet number. So valence will be how much? Therefore, formal charge equal to sulfur valence electrons are how many? 6, and minus there are lone pair of 4, minus half into how many bond pairs are there? 1, 2, 3, 4. No,
Yes,
4
sir.
2 is 8. So 2 4 is 6. It will be 4 minus 2 means plus 2. Actually, this is formal charge we are going to calculate based on the Lewis dot structure only, right?
Yes, sir. But if we take double bond, we'll get
It will go
0.
beyond 8, no?
Yes.
Yes or no?
Yes, sir. It will form more than bond.
Uh, okay, that's why we need to calculate like this. First, we need to write the Lewis dot structures only. From there only we can write.
Okay.
Sir, how can we know that where we have to take double bond and where we have to take single bond, sir?
Just simply we are going to fulfill octet at every atom only. Okay.
Okay.
Next one, limitations of octet rule.
Sir, the sulfur problem only is an example for this, sir. Limitation.
Yes. Limitation of octet. In the limitation of octet rule, what we are going to get is simple. First point is there are certain compounds are there. Okay, those molecules are existing. That means what? Certain molecules, even though they are not having 8 electrons in its outermost shell, certain molecules are existing even though octet octet is not present at central atom. That means simply we can say there are certain molecules with electron deficient molecules, we can say. Electron deficient molecule. The electron deficient molecule means what we can say. For example, BaCl2 if I'm taking. BaCl2. So as per the Lewis dot structure, we can have like BaCl2 we can write like this only. Now see, in chlorine how many electrons are there? Now see, this chlorine having 8 electrons, right? Whereas this chlorine also having 8 electrons. Whereas coming into beryllium, how many electrons are there? How many electrons are? 4 electrons only, no?
4, sir.
Similarly, in case of BF3 also. BF3 also, how we will write? BF, F, and F. Now see in fluorine, each fluorine having 3 bonds. Sorry, not 3 bonds, 3 lone pairs. Now in this one, see fluorine, how many electrons are? 8 electrons. Fluorine also 8 electrons here. This fluorine also 8 electrons. Whereas central atom boron, how many electrons are there? Boron, how many electrons are there?
5.
5. How 5, my dear?
Sir, 6, sir.
Hmm?
6,
6,
sir.
no?
6.
6 electrons are there. Very good. And similarly, take AlCl3 also. In AlCl3, how many electrons will be there? Same like this only. So at aluminum, there are 6 electrons are there. Now see, here in this case, aluminum is electron deficient. This is electron deficient, and this also electron deficient. So even though these are electron deficient molecules, but still existing, right? Are you getting Nana? So these are the electron deficient molecules, still they are existing. In the same way, what we can say, uh, molecules having more than octet. More than octet means what? Having more than octet,
More
more than 8
than 8
electrons are there.
electrons, sir.
For example, if I'm taking PCl5, so it will be like this. So 5 bonds means how many electrons are a total phosphorus?
10, sir.
10 electrons, no? That means more than octet, no? For example, SF6 also. In SF6 also, how many electrons will be there? Like this, it will be there.
12, sir.
Okay, this sulfur having
12,
12
sir.
electrons in the valency. Very good. Like as we had said in earlier case, we have said H2SO4. Generally, it will exist like this. In this one, how many electrons are there? Sulfur
8 electrons, sir.
8. 1, 2, 3, 4, 5, 6. No, 6 to the 12
12,
electrons.
sir.
Kada. 12 electrons. No. So these molecules is not explained by why these are there. And one more thing is there. Okay, there are certain molecules with odd number of molecules also they are there. So odd number of molecules also not explained. Okay, there are certain molecules in which odd number of electrons also there. That means the bonding in odd number of molecules, the bonding in odd number of electron molecules are not explained.
Sir,
Tell me.
sir, in H2SO4, we can keep for oxygen all double bonds, no, sir.
But hydrogen, where you can place? If you are
Okay,
keeping,
sir.
no, how hydrogen you can place, Lana? Tell me.
Sir, here hydrogen and oxygen have which bond, sir?
Sigma covalent bond only.
Okay.
Covalent bond, it will be like this. Okay.
Yes, sir.
This is about the octet rule and their configurations. Okay.
Sir, is it explained now, sir, in recent times?
Yes, yes, it was explained.
Okay, sir.
Okay. Next one,
Could
I
you give
haven't
an
explained day to bond, right?
example of
We will write
yes,
that
sir.
like NO2 minus O2 minus, okay, NO.
Yes, sir. So,
Okay, these are the examples. Uh,
okay, sir.
we have explained about this one. Uh, mm, day to bond, I said coordinate covalent bond.
No, sir.
No, sir, we stopped at only covalent bond.
Mm. Next one, coordinate covalent bond.
Sir, once can you go to the previous slide?
1 second, Nana. This is also called as which bond?
Day to
Day
bond.
to bond. Hmm.
So the previous one, the slide.
Hmm. Done, Nana?
So 1 minute.
Sir, after this, can you go to the next slide?
1 second, 1 second. That girl is writing, no? Let her complete, then we will go for the slide. But
So complete.
okay, but still, you are getting notes, right? But I don't know
Yes.
why you are stopping me right now. Okay, students. So next one is what we can say coordinate covalent bond. Generally, how we are going to calculate a coordinate covalent bond? Okay, how we will calculate? How we are going to define coordinate covalent bond? What is covalent bond? How covalent bond will form?
Sir, the two atoms will share electrons, sir.
So mutual sharing and a mutual contribution, right?
Yes, sir.
Yes, sir.
In coordinate covalent bond, what will happen? Okay. In this type of bond, so one atom will give 2 electrons. Okay, one atom will give 2 electrons, and remaining is going to one atom is going to accept. Understood what I'm trying to say? Now, have you understood what I'm trying to say? So actually, day to bond is going to form by in this one. What will happen? So one atom will donate electrons, 2 electrons, and the 2 electrons are equally shared between 2 atoms. In earlier case, how it was there actually? It was there like both atoms will give one electron and both electrons are shared, isn't it? Yes or
Yes.
no? In covalent bond. Whereas
Sir,
in
I
this one,
didn't
what happened for
understand
the
your
bond
voice, sir.
formation, the required electrons will be given by one atom. Okay, that means one atom will give two electrons, and the two electrons are equally shared between two atoms.
Sir, I didn't hear your voice, sir. Can you repeat once?
Actually, day 2 bond means in this one atom donate two electrons to the other atom, and the two electrons are equally shared between them. Okay, I will explain, please wait. Shared between them, and day 2 bond is represented by okay. That means, for example, let me take between A and B, two atoms are there, and B is having some vacant orbital, and A having lone pair. Okay. Now what will happen? This lone pair will be given to this. That means between A and B, that lone pair is there, and this lone pair is completely attracted by A as well as B. Whereas the donor is what? A atom, no? So for that purpose, how we can represent this? This we can represent like this: A to B. That means A is donating electrons to B. In this way also you can represent, or you can represent A plus B minus. We can represent like this also. Okay, na? How I am doing? So that means between A and
Yes,
B,
sir.
if I am saying the bond is forming, na, in that one, what we can say, A is donating and B is accepting. Let me take some examples.
Sir, can you explain it once again? I did not understand.
Okay, let's take an example of formation of H3O plus. Okay, formation of H3O plus, how it is going to form. See, generally first H2O is going to be there. Okay, H2O is going to be there. So H2O, how it will form? See, oxygen, hydrogen, hydrogen, and there will be two lone pairs are there on this oxygen. And H plus means what? Generally hydrogen means one electron. Okay, so hydrogen is one electron, no? So H plus means what? Generally hydrogen means having only one s one electron, whereas H plus means what? We are having zero. That means there will be empty orbital. Now what will happen? These two electrons are given to this. So by donating this, we will get like this: H2O to H plus.
Sir, on the right side, 4 plus is equals to what you wrote, sir? 1s?
4 plus, Nana, H plus it is, H plus. 1 is 0, no? H plus means what? One electron removed, right?
Okay, sir.
So 1s1 means what we'll write? We'll write like this. And 1s0 means what? There will be some vacant orbital, right? Like this. So in this one, see, in H3O plus, what we are observing? Oxygen is donating because having electrons, and H plus is having vacant orbital, so that it is accepting the electrons, isn't it? So this type of bond formation only we are saying that day to bond we can say. Whereas let me take one more example. Okay. Formation of NH4 plus. In this one, what we can say, formation of NH4 plus means, so we are having NH3 and H plus. Can you try how this bond will form? From where to where electrons will be donated?
Sir, from nitrogen to hydrogen.
From
From I think nitrogen to hydrogen, sir.
so nitrogen, how many electrons are there? See,
One no, sir.
one lone pair here and three hydrogens. Okay. And H plus means what we can say? We are having one electron, one vacant orbital, right? Now what will happen? This lone pair is given to this hydrogen. That means what we can say, from nitrogen to, okay, to hydrogen electron is given and the charge we are taking as +1. Okay.
So here nitrogen is giving that 2 electrons, sir.
Yes.
Sir?
Ah.
Okay.
Sir, can you explain once again the second formula? The second example?
Have you understood first example?
Yes, sir.
In the same way I have done, no? Because see, in NH3 and H4 plus, NH3 having one electrons, isn't it or not? Lone pair is there on NH3.
Yes, sir.
And H plus means what again? One vacant orbital.
Yes, sir.
That we are going to give to, that lone pair is given to that vacant orbital, right?
Yes, sir.
Sir, I have a doubt.
Hmm.
Sir, in the first example, hydrogen already has 1 electron, na, sir. So 2 electrons are given means it will form 3, na, sir.
Hydrogen having 1s1, but the molecule is H plus, no?
Oh, okay, sir.
Okay,
So it will have.
right? In the same way, one more example is there. That is formation of NH3BF3. General, how it will be there? See here. Same as we know, nitrogen having 3 hydrogens. And BF3 means what we can say, 3 boron atoms are there. And at boron, we are having some vacant orbital. Okay. You can identify, sir, how to identify within BF3 vacant orbital is there or not. Just we will discuss one more concept. After that concept, you will get clarity. Okay. How to predict vacant orbital, whether there vacant orbital is there or not, that we can predict actually. Now what will happen? This lone pair is given to this, so that it will form in this way. Okay, now students? Students, am I clear?
Yes, sir.
Yes.
In tomorrow's class, we will discuss about the valency bond theory. That means how covalent bonds are going to form. Okay, how covalent bonds are going to form will be discussed tomorrow. Okay, Nana?
Covalent or coordinate?
Okay, sir.
Coordinate covalent bond already I have discussed, no?
Sir, this much only, sir.
Yes, this is only. Tomorrow, how covalent bonds are formed. Actually, covalent bond definition we have said. Okay, just to two electrons it will share. Okay, by sharing of electrons only we will get the bond. How that sharing of electrons will take place, that we will discuss tomorrow.
Okay, sir.
Okay, na?
Thank you, sir. Bye.
Thank you, sir. Bye, sir. Good night, sir.
Bye, Nana.
Thank you, sir. Bye, sir.
Thank you, sir. Bye, sir.